Phasor, our voltage as a phasor will be 100 angle negative 30. And our current as a phasor will be 2.5 angle negative 60. Okay, so now we know that, or I know the way I would do this.
Is that like every single power question he can even ask, or like a
Pretty
power
much, yeah. What I would say, the way I would do this, since I already have them as phasors, I would say my complex power is V times I conjugate. So, and I think that's the easiest way to do it. And so that's V is 100 angle 30. All right, 100 angle negative 30. And I conjugate is 2.5 angle positive 60. So that gets me 250 angle 30. And what are my units for complex power? VA. See if I have the answers to these. Not that one. Nope. Maybe this one. Nope. Nope. Okay. All right. So now we want to get the apparent power. So what is the apparent power?
Magnitude complex.
And so what would that be here?
250.
250. And units?
VA.
VA. Okay, now it says average power absorbed. So this is where I like to write my S as P plus JQ. So I change my complex power from polar form to rectangular form. So it was 250 angle what was our angle?
30.
30. I have this set to polar. So 216 plus J 125. So what is our real power or average power absorbed?
260 watts.
Yep. And what is our reactive power?
125.
And what are its units?
VAR.
VAR.
So with the values in RMS?
Yeah, well, it depends on what, these should be RMS values, and I did not do that. These should have been RMS. Yeah, this should have been RMS. And so, and they were not RMS. And so thank you for correcting that. So, how do I know they're not RMS?
Don't tell us.
Well, not only that, no, I actually know in this case. In this case, I know they're not RMS. I can't blame this one on, oh, the problem doesn't say. I would like to, but no, this is on me. I missed something. It's given to me as the sinusoid. This number is the max number. It's not the RMS. The 100 is the maximum. And so if I had RMS, then I would be good here, but I don't have RMS, so let's see.
So you just have to convert it to the RMS?
No, I just have to put in a 1/2.
It's 1/2, yeah.
Yeah. So I just have to put in a 1/2.
Huh.
Because what did I tell you the RMS of a sinusoid was?
Just like whenever we're looking at like the sine or cosine.
Just a sine or cosine, yeah. What
uh,
was
the mean value of it.
the RMS value?
Yes.
What did I tell you that was?
The average value of
Yeah,
it.
the actual number, like I said, for any sine.
1 over square root of 2 times sine for sine would be times sine, for cosine would be times cosine.
Okay, V and I are both sinusoids. So
Okay.
their RMS values would both have a 1 over square root of 2. So if I take a 1 over square root of 2 times a 1 over square
1
root
over
of 2,
2, okay.
I get a 1 over 2. So this would have been 1/2 of that, which would be 125. And each of these would also be by half, but I'm not certain on that. Let me check that. 125 angle 30. I think yeah, that would be right. 125 angle 30. $108 plus 62.5. Yep, that's half. 108 plus J 62.5 VA. So our real power is 108 watts. And our reactive power is 62.5 VAR. And I remember on our very first test in power, when I took power, there was a problem where almost all of us got like 3 or 5 points off because there was a problem where we did not realize it wasn't RMS and we didn't put in the square root 2.
So you can only find the apparent and absorbed power if you have the RMS values?
Well, no, those are the RMS values of the apparent. It's, so, let me show you.
Oh, so you're finding the power of the RMS. You can find the power either way, but we're looking for the apparent power RMS.
Yes, but that's typically what you mean by that.
Okay.
So yes.
I
So
see what
that's
you're
the
saying.
definition, yeah.
You only find apparent power with the RMS. You don't usually find it in the regular function.
You don't find it with the maximum value because
Maximum value.
because it's not operating at the maximum value all the time. It's operating at some average of that.
Okay, that makes sense. And that's why you times it by half, because like that converts it to RMS.
Right. Does this have this? It says it's the solutions to 9. Let's see if it's really the solutions to 9. I don't think it is. I don't think it has this one.
Yeah, you went over this on your Zoom?
I went over it on my Zoom. No.
Did you went over it like in one of your essay sessions that's on your Zoom record?
Oh yeah, on a bunch of them.
Okay, then that's okay. I'll just in the spring break I'll worry about it.
Okay, all right. So then what else do we have? We have whether it's the power factor. Okay, so we need to get the power factor. And so the power factor is defined as the cosine of the voltage angle minus the current angle. And so our voltage angle was -30 minus our current angle was -60, so that's -30 plus 60, or the cosine of 30 degrees, which is 0.87 something. .866. Oh, 0.87. So that's our power factor. Now, is it leading or is it lagging?
It's lagging
It is lagging. And how did you know that?
because the current's lagging.
Because the current's lagging. So if you look at the angle of the current, it's -60. It comes behind the angle of the voltage. Okay, so there we have it. All right, and then for the next one, they give us the root mean squares. So we have 440 angle 0, so V RMS is 440 angle 0 degrees and 0.5 angle 75 degrees. And these are RMS. So because they're RMS, I do not need to put the 1/2 in. And so our complex power is going to be 444 angle 0 degrees times the conjugate of I, which will be 0.5 angle -75 degrees, which is 222 angle -75 degrees. Okay, and then next step to find the apparent power. What would the apparent, and what are the units on complex power?
VA.
VA. And the apparent power would be
222.
222 VA. And then how do I find the real and the reactive power?
P plus JQ.
That's how I find it anyway. So second complex. I say that's how I find it. What are some other ways to find it?
Sine cosine.
Yes.
Yeah.
So I'll go over that as soon as I get this. So 57.4 minus J214. And that's still VA. And so then my real power is 57.4 watts. And my reactive power is negative -214 VAR. Is this a capacitive or an inductive circuit?
Passive.
And we know that because,
The imaginary component is negative.
that's right, and the reactive power is negative. Let's see, did I have it open on this computer? I did. So we have all of these formulas right here that you can use to get the real average power, the reactive power. So you could also take V RMS, R RMS times the cosine of, well, times the power factor. And then to get the reactive power, you do the sine of the angle. And then if you had some of the other stuff which we don't have. You could use that to find the things. Notice, let's find the power factor this time. Let's find it this way. So P average over S, and just verify we get the same thing. And so our power factor, another way to find it is to say it's P over S, which is 57.4 over S was 222. Can someone just tell me what that is?
Yeah,
0.259. And that makes sense if I take my voltage angle minus my current angle, which in this case would be 0 minus 75. And I draw that triangle. And I put 75 there, and this side is the apparent power, that's the real power, that's the reactive power. You can also find it using the power triangle that way. But just to verify, someone tell me the cosine of negative 75.
0.259.
And that's 0.259, which hopefully is the same thing we just said. Yes. All right. And leading or lagging, did we say yet? Yes, we did. Or did we?
No, wait, first one. Not for a second.
Okay, so is it leading or lagging?
Leading.
It's leading. So what goes together with leading, capacitive or inductive?
Capacity.
Capacitive. All right, so that's that one. I'll just go ahead and do another one on this same recording. There is another problem, right?
Yeah. Problems as well. Session 3 problems as well.
Okay,
We already did them as well.
we did 12?
Yeah.
Okay, all right, then 13. Oh, good, yeah, okay, good. We needed to do this one. Choose the load impedance so that the power dissipated is maximum. What is that power? Yay, something new. Okay, so we want to find the load impedance so that the power dissipated is maximum. What is that power? So what ends up causing your power not to be maximum? What sort of things would do that?
Whereas,
If the capacitor, if it's more capacitive or more inductive.
Yeah, because you want the reactive power to be 0, because the apparent power, what you have to produce, includes the real power and the reactive power, but you don't get any work out of that reactive power. So you want your load to cancel out any of the imaginary stuff that you have in the rest of the circuit. So, and then you know from circuits 1 that you want the value of the resistance to be equal to the resistive part of the circuit. So what we want to get maximum power is we want Z for max power is going to equal Z Thevenin conjugate. Because if you get the conjugate, that when you add it together, it's going to cancel out. So we have to find Z Thevenin for the rest of the circuit. So shouldn't be that bad. We already have them as phasors. So it will be, we've got a capacitor in series with a resistor and an inductor in parallel. So it's minus J4 plus 4 in parallel with J2. So this is Z Thevenin, is minus J4 plus J8 over 4 plus J8. Does anybody want to do that by hand? I don't. Uh-oh. Okay, so it was J4, what was it, plus J8?
Negative J4.
Okay, thank you. Negative J4 plus J8 over 4 plus J2. So minus 0.8 minus J2.4? Is that what y'all got? I think I do have the solution to this one. All right, so what does Z load need to be? Yep. So we want Z load to be 0.8 plus J2.4. And now our maximum power will equal V Thevenin squared over 4 times the real part of Z Thevenin, which is the resistive part, which I don't know if you remember it or not, that's the same formula that you had for DC circuits. It was V squared over 4R. And so we have to get V Thevenin. So if we had, if this is 20 angle 0, V Thevenin, so just looking at our circuit, let me draw it again here. Inductor. And our load is right here. And that was 20 angle 0 J2 minus J4, or 4 I think. Yeah, 4. Okay, so V Thevenin, how are we going to find that? So V Thevenin is the same as V open circuit. So it's the voltage across that load if there were no load there. We're going to do voltage division, because does the capacitor play any role in getting V Thevenin? Because it's V
No,
open
so-
circuit.
Right.
Yeah. So we don't need to worry about the capacitor. So V Thevenin is going to be 200 angle 0 times J2 over 4 plus J2. Because we just need to get the voltage across this inductor.
It'd be 20, right? The voltage source.
Oh, yeah, thank you, 20. And so then that is going to be 20 times J2 over 4 plus J2 is 4 plus 8i, but let's get that as a phasor. So it's why is it not giving it to me in the somebody tell me what 4 times the square root of 5 is.
I got 8.9.
8.9. Okay, I only need the magnitude part. What was it?
8.9.
8.9. I only need the magnitude part, because you see how this is absolute value? That's the same as saying magnitude. So it's 8.9 squared over 4 times the real part of the impedance, which was 0.8. So, I get 24.7.
Yeah.
And what would the units for that be? Watts.